All right, I think we can get started here. Hello, everyone. My name is Danny Gem, and I'm the National Marketing Manager at ChickTech. And I'm excited to be introducing today's session. So welcome, first of all, and thank you all for joining us for Microservices Architecture Explained for Everyone with Monica Tamboli. Monica holds a master's degree in computer science and enjoys being a mentor for high school and college students. She also likes to volunteer for technology and engineering camps for kids, which of course as a Chick Tech employee, I love that. Welcome, Monica, and take it away.
All right, can you hear me okay?
Yep, sounds great.
Get started. Thank you, I'm so excited to be here. My name is Monica Tamboli, and today we'll be talking about microservices. We live in this world where it has become important to get products in the market quickly. So microservices help us get our new features in your applications developed, tested, deployed, and updated quickly, especially if we are considering cloud. Here's a little bit about me. I work for IBM. I'm test lead for a product called WebSphere Hybrid Edition, which is a bundle of server runtimes, as well as tools for modernizing existing applications. As a test lead, my goal is to use our products as customers would do to ensure quality. So as part of that, my team write applications and consider these different architectures we are going to discuss to represent our diverse customers. Also, we run these applications on physical machines, VMs, as well as on containers in Kubernetes clusters. So agenda for today, we'll discuss, we'll start with an analogy and then move on to different software architectures with focus on microservices. We'll have more examples, summary, and then some resources to share. Let's start by meeting the Johnson family. Mom takes care of all household chores, cleaning, laundry, cooking. Dad is the sole breadwinner. Sam, Mom, I can't find my jacket. I'm getting late for school. He's very disorganized. Judy, oh, the same food again. Jack, who just started college, is struggling to live independently. He's late for classes, not doing well overall in college. So here we have a family which is very tightly coupled. Coupling here means the degree of interdependence. So they depend on each other. Let's imagine mom gets sick. Who is going to take care of all the chores? Dad loses his job. Our kids will be able to survive in the college. So I think the question is the family ready for 21st century? So what can we do to get this family be more prepared for new world? Here are some of the things which can be done. Mom takes a part-time job. Dad helps with some of the chores. Kids have their clear responsibilities of cleaning their rooms, doing their laundry, preparing their lunches, so they know what goes behind all those tasks and don't take it for granted. So the idea here is defining clear responsibilities and expectations and making everyone independent. So from tightly coupled family, we have a loosely coupled family, but highly cohesive. So with this approach, we have more flexible, independent, responsible, and prepared to handle any challenges family. Like if mom have to go on a trip, everybody can survive without having any issues. So now let's take that Johnson family analogy and applies to software architecture. Actually, I thought of this analogy when I was learning about microservices, thinking, oh, I probably want to have my family more like microservices, especially my kids, whom I want them to be more independent, confident, and resilient. So in the same fashion, software architecture talks about designing your computer applications, right? How the different components will interact with each other. So here we are talking about two different architecture. One is monolith, where everything is tightly coupled. These are all the different tasks here. And microservices, where everything is more, they are more loosely coupled, independent modules here or components here. So again, why this is more important is because these days, as we talked about, we want everything, all new features done quickly, and containers and cloud is becoming popular. And this new architecture of microservices work really well in that. So here we can also, the term used is also called like modernizing applications. Sometimes people who are running these monolith applications, which is a big application running, want to make it divide their application. It's the term modernizing the applications. Also, another term used is lift and shift, where you take the entire application as is without making change and move it to cloud. That's more of a lift and shift. And modernizing application is changing your application, existing application, and moving to the new architecture. Okay. So let's just dig a bit deeper onto these architectures. First, what's monolithic architecture? As we talked, different tasks interconnected in a single unit. So easier to develop. Imagine the first program you guys wrote. I looked at the poll results. I know everybody has done some kind of programming. So, you start with your first application, you start writing different modules. They are still, you write functions, you separate it out, but it's still one application. When you compile, you deploy as whole. So they are easy to deploy, less worry about security and network latency because it's on the same network. All the calls are internal calls between different components. What's the problem with this? Imagine your enterprise application growing, right? You started with something small, now you added more features, it's becoming too large. So monolith actually means a big rock. So it can become difficult to manage, like it will be difficult to move a rock. So that's why the term monolith here. Again, if you made a small change to any of the component here, you have to redeploy the whole application. Not easy to scale. So now you saw that your application is getting popular, a lot of clients are accessing it. You need to, it's getting slower, you need to scale. Although only one component might be getting loaded more, might be causing bottleneck, but you can't only scale just one thing. You have to replicate the entire application, which means like more resources, more hardware resources as well. And also difficult to adopt new technologies, whether it's programming languages, other frameworks. Let's say you need to add another feature and the developer is more comfortable using Python versus Java. It becomes difficult in this architecture. So now let's see how microservice architecture is different. So as we took our example earlier, here, all these components, different components are individual smaller tasks as opposed to a single application. So these are like micro applications, so small applications. But there are certain rules which make these applications work, this architecture to work better for your needs. Before we discuss the advantages of microservices, I just wanted to mention, some of you may have heard about SOA, service-oriented architecture. Yes, there are many similarities between microservices and SOA, but they are different. SOA had dependency on enterprise service bus and other differences. All right, so let's discuss how microservices are better, why they are becoming popular here. So they are easy to manage because of their small size. There could be a smaller team working on each microservice. Updates are easier to make. A lot of you probably heard about DevOps model, where you combine software development and operations to work together so that features can be delivered at a high velocity. Since dividing these your tasks into microservices help support that, now you can make updates only to one thing as opposed to the whole application. So now you can just take one microservice and scale it as your needs change. As we talked earlier, now if your developers want, they could, different teams could use different languages if they desire. So yes, there are a lot of advantages of having this architecture, but it comes with its own shortcomings or challenges. One of them is complex intercommunication between these services. There is more, now they could be on different networks. So there could be more network slowdowns. What if network is not reliable? And also, as having communication over a network, HTTP calls, you need to be more aware of security considerations. So here we will take an example of, let's take a fictitious airline system. We'll call it Acme Air. It's an open source application. So in this case, our goal is to, query flights, book flights, look at the account of a individual user. So we'll consider, first, let's consider the monolith Acme Air. In this, you have your browser client, that's you sitting on your computer, trying to access this application here. Application is again divided into different modules, but they are just packaged together. And here there is a central Acme Air database where all the information is stored. As you have more and more people coming to the website to reserve more flights and things like that, you would need to scale. So you can see that the application has been scaled multiple times. But again, there is this challenge that the whole entire application has to be scaled. You could not just take booking during summertime and scale that if that was causing the bottleneck. So here is the same application. We are going to see how we can divide it into microservices here. So again, client here, these are all the microservices, all the rectangles. And these are the databases. So you notice that each microservice is having their own database here instead of central database. And they still talk to each other through, they have to decide how they want to communicate. In this case, let's say they are doing HTTP calls. So in this case, we can see that these are more independent. So all these microservices have their own code repository. Different teams, they use different languages if they need to. So they are easy to develop and test. They are scalable, so you could just scale one service at a time. Again, perfect for DevOps. If you have like CI/CD pipelines, you have automation where one service is changed, only that needs to be updated in your production environment. Also, this model can be very resilient in a way. If one service is not working correctly or down, customers can still, they won't have full experience, but they will have some experience. By the way you design your microservices, you can handle that. If one particular service fails, customers can still access other services. So overall, your application could be more resilient. So here we have discussed, about an example about microservices, why they were great in current times. There is another, containers and Kubernetes are also becoming very popular these days. And microservices make great choice to run in containers and in Kubernetes. This can be a detailed topic, but I'll just touch on this, what containers are. So they are like, you can imagine them like shipping containers. They are self-sufficient, doesn't matter what's in there. And they can run, like you can ship these containers on anything which is made to take these containers. It doesn't matter what's in there. Similarly, your applications can run on any cloud, wherever the containers can run. Containers let you pack application along with all the dependencies. So it makes it easier that you can take the same image from developers desktop to production. We are all used to listening like, oh, developers saying it works on my computer, but you will be running the same image, whether it's desktop or production. So that's really helpful. Since microservices are small services, so they make a great applications to run in containers. And as you need to scale, you just start more containers. So with that, you can imagine if you have multiple microservices, lot of containers running, you need something more to manage the life cycle of these containers. So that's where Kubernetes come into picture. So Kubernetes is something which helps you orchestration for these containers. It helps manage the life cycle of these containers. So at this time, we discussed that microservices are great, but they are not easy to design. They are not easy to manage. So there are different resources to help you create the microservices which will reap the benefits we talked about. Because if we did not design them correctly, they could be distributed monoliths. So here the 12-factor app is very popular practices for creating such microservices. they talk about how, like, for example, you need to make sure your code base is different for all the microservices, how the dependencies need to be managed, the config, how you would save your config. So all those factors are discussed there. Since I work in Java EE microsystem, I wanted to discuss about this open source specification called Microprofile, which is great if you are looking into developing microservices for Java EE. And Open Liberty is one very lightweight application server. It's open source by IBM, which is great, provides implementation of microprofile and makes a great runtime for running microservices as well. But there are multiple frameworks which are helpful, which are to create your own microservices. One more thing I want to mention here is, as we discussed with microservices, the big challenge is how do you manage these microservices? So service mesh is something which is also gaining popularity, especially in Kubernetes clusters, where it's an infrastructure layer which handles the inter-service communication of microservices, like service discovery, load balancing, health check, security, etc. So at this point, we have covered two different software architectures, monoliths and microservices. But there could be more, there could be a spectrum of architecture styles. Here we are saying there could be something called macroservices, where you are trying to balance advantages of monolith as well as microservices, trying to reduce network calls a bit, but still divide them. So here are functions which are again taking, even splitting your task to a very low level. Like, for example, example of function could be just, if you have a Google Cloud storage and you upload something and you get an email, so that function could be just, sending an email. So it could be a very small task. So one point I want to make here is that what architecture style works for your application would depend on how your teams are structured within your company, within what the needs are, where do you see, where would these applications be running. So on that, I have this next slide. This is I would use this something like this as a tool in deciding what architecture works best, depending on what your goals are. For example, if you see that there will be new features coming very often, then going towards microservices would be beneficial. Again, if you don't want too much network demand, then going with the monolith would be helpful. And the last one here on the pricing. So with monoliths, it could be more capital upfront, then there could be more operation cost when you are moving to microservices functions in cloud. So before I go to summary, are there any questions in chat? I just looking to see it. I don't see any comments. And
yes, please, if anyone wants to either unmute themselves to ask a question or post their question in the chat box, that would be fantastic.
Yes, thank you. So we'll summarize our discussion here. So the very first point we want to make is, like, microservice is also just a computer program but important thing is for a specific task. to reap the benefits of this microservices and microservices architecture we discussed, they need to be designed appropriately, making sure that, for example, we are not sharing the database between all the microservices. Again, microservices work great for DevOps. They were great if you want to have automation, CI/CD pipeline, continuous integration, and deployment, so that when any specific microservices needs to be updated, you don't impact any other running services. Again, as we discussed, that microservices make great choice if you are considering containers and cloud. And as we discussed, they may not be the right choice for everyone, especially smaller teams. They become more beneficial as your teams grow. There are different teams. You want them to be focused on their needs. They want to use different technologies, different languages. I heard about somebody talking about, when that you want typically like a team working on microservices would be big enough where you can feed them 2 pizzas. So that gives you a rule of thumb, how to split your microservices, like how big it should be. That can be handled by small team. So here are some resources if you want to learn more about microservices. There are some great guides on this link. You can develop a simple microservices using Open Liberty. Acme ER example implementation, and can learn more about 12-factor app and learn more about microprofile. I just realized that I did not give the URL, thinking that slides will be shared. If that's not the case, I'll be happy to share the URLs on the chat after the session.
Oh, that would be perfect.
Yeah. All right, that concludes my session. Thank you so much, everyone, for taking time.
Thank you so much, Monica, for sharing your experience with us. This was fantastic. Just a side note, so there will be a follow-up session on August 5th with Microsoft Learn TV. I'm dropping the link in the chat boxes. Monica will be there to follow up on this discussion and chat more about this topic. So please feel free to register for that. Within Act W, coming up in about 15 minutes, we have a mindfulness yoga session with ChickTech's board president, Nancy. So please head over to the agenda if you would like to join. And with that, thank you so much again, Monica, and thank you everyone for joining.